Good morning, good afternoon, good evening, and good night. My name is Jeremy Antonio Gunawan from the class Numerical Method 1. Today I'm going to tell you about the assignment from Mr. Dai, our lecturer. And at that week, he gave us an assignment to use the software CFD soft to find the relationship between pressure drop and fluid discharge. And we'll try this by trying 10 different variations of the inlet velocity, and we'll also try curve fitting analysis using Python coding on the relationship to find the exact pattern. So we'll start. The first thing you do is import the geometry file, and then according to the assignment, the assignment was a gate valve. So the first thing to do is uniform scaling. So to make sure the three axis fits, and don't forget to try to box the mesh dimensions to get these dimensions. It has to be exact, so uh, it will not go into error. After that, we'll put maximum level 2 at the surface refinement and layer mesh parameters as such. And then don't forget to put the box mesh boundaries. X negative is inlet, X positive is outlet, Y positive is wall, and the others are boundary. And then before generating, don't forget to put the mesh location inside and right directly at the middle of the valve between like the radius of the inlet and outlet valve. So this is the mesh location that my geometry shows, and then I checked if the mesh was okay, and it was. Then so we can continue. So before simulating, we have to set up a few requirements. The first thing you do is change the turbulence to runs at ANS, and then a new tab will pop up. We'll change the turbulence model to SST-K omega, and then the material to air. And then the next thing we do is putting inlet boundary conditions. We'll start with 1, and don't forget to change the inlet into velocity inlet, the outlet into outflow, and the wall into stationary wall. And then we'll try to run the simulation. We'll set the iteration to 1000 and the interval also 1000, and then we'll run the simulation. Now after the simulation is done, we'll go to another software, which is ParaView, and we'll input these formulas. P static, static pressure, U is the magnitude of the velocity, dynamic pressure, and the total pressure. After using these formulas, we can get these datas, the total pressure of the inlet and the total pressure of the outlet. And then after doing that, we can use these formula, which is Q equals A times V, fluid discharge equals area of inlet times velocity. And then this is the data we got. So the first reference value for self velocity I got was 1. Input was 1, sorry. And then this is the data. And then I continued with 2, 3, 4, 5, 6 until 10 meters per second. The next thing is I wrote the code using the CFD sys software, and this is the script. You can see importing numpy, importing matplotlib, and putting the x and y, the data as that we got from ParaView, and fitting the parameters and showing the graph. So this is the graph using the curve fitting analysis that I got. We can show that the graph show that fluid discharge is directly proportional to pressure drop. So the higher the fluid discharge and the higher the pressure drop is, and vice versa. And thank you for listening. Goodbye.